Hi everyone, so we're on video number 7 for your summer work. And I like to call this video, What in the World is Factoring? So in Algebra 1 this past year, you spent a lot of time factoring trinomials, binomials, polynomials. But factoring really just it's like splitting an expression into multiplication of simpler expressions. So these are actually two factored expressions. So you can see x plus 2, x minus 2. These are binomials. And if I wanted to make them a bigger expression, I would multiply them. So if you multiply, remember your teacher might have called it FOIL. I don't really like to call it that, but you'd multiply x times x, you'd get x squared. X times 2, and I actually use arrows, gives me negative 2x. 2 times x, which gives me a positive 2x. And then 2 times negative 2, which is negative 4. Then you combined the like terms, and you would get x squared. And these two terms would cancel out because they are opposites, and you get x squared minus 4. Okay, so this is the polynomial. In this case, it's a binomial. And if you factored it, you'd be putting it into two binomials, okay? All right, here's another expression that's already factored. And again, this would have started in this place right here. It would have started if you had FOILed it. So 4x squared minus 2x plus 2x minus 1. These canceled out, and you had 4x squared minus 1. All right, so this is what you would have started with. Factored form would be this. So it's kind of like working backwards. All right, now the big thing about these two is these are actually a very special pattern. Factoring with a pattern can be really easy. And so today we're going to be talking about this pattern I love, the difference of two squares. And I love it so much that I gave it its own name. I like to call it dots. Dots is the difference of two squares. Now, difference means that they have to, what you're going to get is different, and difference means subtract. All right, so if I want to factor this expression, x squared minus 25, let's look back for a second. What do you notice about each of these two binomials that we gave here? What I'm hoping you notice is that they're exactly the same, except they have opposite signs. And that's actually the pattern. So x squared minus 25, you can factor into two binomials. One will be plus, one will be minus. And the first term will be the square root of the first term, so x and x. And the second term will be the square root of the second term, so 5 and 5. All right, now we still always want to check to see if there's a GCF, but there is no greatest common factor between each of these terms. So using the pattern is pretty easy. Let's look at the next one. So I have two terms. They are being subtracted, and each term is a perfect square. So that means that it's dots, and I can factor using the factor pattern. All right, so we have two binomials, one plus, one minus. The square root of 4x squared is 2x, so I have a 2x and a 2x. The square root of 81 is 9, so plus 9 minus 9. All right, let's look at this last one. Well, wait a second. 3 is not a perfect square, and 75 isn't a perfect square, because we also don't want to forget that first thing we should do if it says factor is see if we can factor out a GCF. Well, these both have a GCF of 3, so I can pull that GCF out, and I'd be left with x squared minus 25. And now I can factor because I do have dots. So I have 3, x plus 5, x minus 5. All right, so using dots is a really, really easy expression, but we want to go through the process every single time. So first, see if there's a GCF, okay? That should be step 1. Step 2, is it two terms? If it's two terms, is it dots? Meaning, is the first term a perfect square? Is the last term a perfect square? And are they being subtracted? So let's look at these. Is this dots? Well, hopefully you're saying, well, 2 is not a perfect square, so it's not dots, so we can't factor it using the pattern. I look at the second one. There's no GCF. It is two terms. 4 is a perfect square. X squared is a perfect square. 25 is a perfect square, and they're being subtracted. So now I can use that cool pattern. So 2x plus 5, and 2x minus 5. All right, I hope this was a great review of the difference of two squares, dots, and I'll see you next time.